Hey guys, welcome back to an Oxford Mathematics Admission Test as per October 30, 2019. So we're going back to type G, and here that's the question about logs. So we set up the following equations. That's the first one. Here's the second one. And the last one. Log CA equals B. All right. So we know we have conditions for A, B, and C. They're all positive numbers. And we need to specify basically how many solutions the system have. Okay, so first of all, let's try to figure out some variables through another in order to substitute into other equation. So I set up them as the first one, the second one, and the third. And let's try to do that with the first one. So we can say that B is equal A powered C. And also we can do using the second equation. So we have log BA. So that means log BA can be converted using the log property as 1 over log AB. So from here, we know that this is exactly C plus 3 over 2. And if we swap them, we'll have the following: 1 over C plus 3 over 2 equals to log AB. Alright, so if we express B, basically we powered A, and the power will be 1 over C plus 3 over 2. We'll get the following. So from first one, B equals A to the power C. So from the second one, we have B equals A to the power 1 over C plus 3 over 2. So we can equate them. So 1 in terms of B equals 2. So that's why we'll have A to the power C equals A to the power 1 over C plus 3 over 2. And because the bases are the same, we can equate the powers. Alright, so we have the following: 1 over C plus 3 over 2 equal to C. In order to resolve that, we can say that we have C squared plus 3 over 2C and minus 1 equals 0, but it's better to multiply everything by 2. And we'll get finally 2C squared plus 3C minus 2 equals 0. So obviously, this quadratic equation, let's estimate how many solutions it has. Use discriminant as, remember, just x squared plus bx plus c equals 0. So in order to estimate how many solutions, we can complete discriminant as b squared minus 4ac and find the solution like minus b plus minus square root of discriminant over 2a. So in this case, we'll have the following. So 9 plus 16, which is 25, so a good number. It's positive, so 2 solutions for C. 2 solutions. So hence, in order to figure out them, let's complete according to this pattern. C is minus 3 plus minus 5, the square root of discriminant, over 2a over 4. Okay, so that's why C1 minus 3 minus 5 over 4 negative 2, and C2 minus 3 plus 5 is 2, 1 over 2. So take into account that we have A, B, and C to be positive numbers, we can figure out that C only unique solution. Unique solution. So that's why C should be unique, and we can say that this doesn't work. So we have C equals 1 over 2. Let's go back and see how it works and how to figure out A and B from there. Alright, so what we're gonna do, for example here, A is using 3, A is simply C to the power of B, but keep in mind that C is 1 over 2, so we can rewrite as 1 over 2 to the power of B. Okay, that was with the help of 3. So now we can figure out from the first one, using the first one, we can also express B through C, or we can again remember the property and for the logs and write log AB equals 1 over log BA. So in this case it will be equal to C, so it means equals 1 over 2. So log BA equals 2, and from here A is B squared. Okay, so we have the following. We have A expressed through B and also A expressed through B using 1 and using 3. So what we can do, we can equate them. So simply by equating 1 to 3, in terms of A, we'll have the following: B squared equals 1 over 2B. And this is the right time, or you can rewrite as 2 to the power. Okay, yeah, let's leave as it is right now, and just let's estimate how many solutions might be here in terms of B. So we drop the graph y from B for the left side and y2 from B from the right side. So we'll have the following. The first one, simple parabola or basic parabola, and 1 over 2 to the power of B. So because we know we only have B more than 0 according to on the time these limitations, so that's why we are not supposed to consider the left hand side of the graph. So we just erase that, and we only strictly more than 0, so we exclude that point also. And let's consider the right part of the graph. So this is y1 from B. So on the right hand side graph, y2 is a simple exponent, like sort of a to the power of x. So that's why in terms of B is 1 over 2 power B. So because the base is less than 1, we can figure out that your graph will have decreasing behavior. So means just simply goes something like this, and we can clearly see that there is only one point of intersection, so one intersection. So that's why B will be also unique. So you don't need even to figure out what's the value for that, and we're not going to do that. So just B is also unique, as well as C. So unique solution, and just having, for example, any equation which connects A, B, and C. For example, the first one, so B is A to the power C. So B is A to the power C. So A is basically root power C from B. We can figure out the value for A. But also A is also unique. So that's why all three variables are unique. So the right answer in this case is going to be unique solutions for A, B, and C. So that's why we need to choose A options in type G. So hopefully it was pretty clear, not so hard, just as about simultaneous equations. And sometimes, as you understand, and this is the most the case in Oxford tests, you just need to figure out analytically, sometimes without giving precise solution, or just drop the graph and see how many solutions might be here. This is the typical way of how you need to approach an Oxford mathematics submission test. So hopefully you enjoyed. We'll keep working on other types. Looking forward.